Hey everyone, welcome to this course. Now in this course, I'm going to teach you a step-by-step guide in building a state-of-the-art deep learning mobile application that uses the Pix2Pix algorithm. The Pix2Pix algorithm is a very powerful algorithm that takes in as input a sketch and generates a realistic image of that sketch. Now we're going to build this algorithm in Python, and we're going to be building an API which can generate images using this neural network that we built and display it in a Flutter application. So the Pix2Pix algorithm is a very powerful algorithm that can create a mapping of one image to another image, and this has a lot of practical use cases. For example, you can go to your police station, tell them that you have this app that can take in a sketch of a human and generate a realistic image. So this would help finding suspects. You can also build meme-worthy applications that can be used by the millions. For example, you can generate Pokemons from a sketch, you can generate cats, you can generate dogs, you can generate bags, shoes. So there's a lot of practical use cases for this application, and I'll be teaching you a step-by-step guide in getting the data set and training the neural network and building the API for our neural network, and then creating an interface in Flutter so that the user can draw any sketch that they want. Alright, so I hope to see you inside, and if you do end up taking this course, I would love to see what ideas you come up with after taking this course. It's a very powerful algorithm, and I love seeing the ideas that my students come up with. So I will see you inside, and I hope you have a great time. Okay, so the first thing that we're going to do is create the folder to store all of our code for our Flutter project. So I'm going to find my directory, and I'm going to go into my E hard drive, and by doing this command I can get into my E hard drive. And once I'm in there, I'm going to do flutter create, and we're going to create a project called human generator. Okay? And by doing this flutter create command, it's going to initialize our folder so that we can properly run our project. So okay, so that's fine. And so now we can cd into our new folder, human generator, and we can list out the directory. And as you'll notice, we have our Flutter project folders, okay? So once we're in here, I can run the command code dot. And what this is going to do is open up my coding editor in this current folder. So it's a very handy tool to use, especially if you're a developer. But in order to run this code, you do need to add the binaries of Visual Studio Code inside of your environmental paths so that you can use this command in a command prompt. So once you do that, you can run this command, and if you don't want to do that, you can just open up the directory in your preferred coding editor. Now, once we do that, we can go into terminal here, and we can run our base project just to see what it looks like. Now, we're going to get an error because we do need to run our emulator. So I'm going to go to View, Command Palette, and do Flutter Launch Emulator. So you can write that in, and you'll get all the Flutter commands, and there's a Launch Emulator. Now, you do need to add the Flutter extension in this Extensions tab. And once you add it, you'll be able to use your command palette with all the Flutter commands. You just need to add, what was it? The Flutter package, which is this one. Okay, so you just search up Flutter, and it's going to download Flutter and the Dart extension. And once that happens, we can do Flutter run. And now what should happen is our project that we have stored here in our lib main.dart. This is what's going to be loaded onto our emulator. And once that runs, we can click this button, and we have our base Flutter project set up. Now, it's going to take a little bit, so I will pause, and I will see you guys once this is done. Okay, so my Flutter project has just finished compiling, and so when I press this plus button, this number does increment. And so now we're ready to start setting up our project for this human generator app. So that's what we're going to do in the next video, and so I will see everyone there. Okay, so now we're ready to start our project, and the first thing that we're going to do is get rid of all of this sample code. and we don't want the sample code because we do want to start from scratch for this project. So let's get rid of all the sample code, and the next thing that we're going to do to set up our project is install the required dependencies. So we can go to the pubspec.yaml file, and in here we have this dependencies tab, and what we can do is we can install different packages by specifying them there. So we can install the HTTP package, and we're not going to put a version, and by doing that we're going to get the latest version. The next package will be file picker. Following that, we will do path provider, and after that, cached network image, and finally we want splash screen. Okay, and so once we do that, we can split our terminal right here, and I like to split it because I like to have my project running here and my other code that I would like to put in my command prompt here. And so I'm going to put flutter pub get so that I can get all of these dependencies inside of my pubspec.yaml file. And now that we've run that, we should be able to use all of these packages. So we can head over to our main.dart, and we can start writing out the first class. Now for our main.dart, we do want to have a stateless widget. And so I can write STL, and I'll get this Flutter stateless widget through the extension that I showed at the beginning of this course. And once I do that, I will have all the code for a stateless class. And so I'm going to call this class my app, and we do need to import materials. So we can do import dart material, sorry, not dart, package flutter material.dart, and once we do that, we'll have our stateless widget run successfully. And so now let's create some new files. The first file that we're going to create is a splash screen.dart file, and this is where we're going to hold the code for our splash screen. And if you're unfamiliar with what the splash screen is, it's just the loading screen before the app runs. Following that, we want another file, and this file will be home.dart. And so these are the three files that we're going to use in this project. And so now we're ready to start writing code, and that's what we're going to do in the following lecture. So I will see you there. Okay, now in the previous lecture, what we did is we built this stateless widget for our main.dart file. And so now what we want to do is go into our splash screen.dart, and in here we want to create a stateful widget. Now I can just write STF, and I'll have this Flutter stateful widget pop up, and by just pressing it, I have all the code for a stateful widget. So here I can add a class called mySplash, and it's going to autofill it in all of these places that it matters. And let's import our material.dart package. So here we'll do import package flutter material.dart. Now I also have this extension where I can just do import m, and it imports this package, but that's up to you. And just to clarify, this is being done through the awesome Flutter snippets extension. Okay. So once I do that, we can also import our splash screen package. So we can do import, and in here we can do package splash screen, and in here we'll grab the splash screen.dart. And once we do that, we can return splash screen, and this splash screen widget takes various parameters. Now the first parameter is the amount of seconds that we want this splash screen to be there. Following that, we need to specify navigate after seconds, and this is the widget or the class that's going to go to after the seconds elapsed, but we'll fill that out afterwards. Next is the title, and this title will have a text widget with the name face generator app. Okay, and let's add some style to this text widget, and we'll do style is equal to text style. And in here, we want font weight to font weight.bold. Following that, we will do a font size of 35, And finally, a color of colors.white. Awesome. So once we do that, what should happen is we should have this text widget appear. So I'm going to add commas. And I also have another extension that formats on save. So there's this extension called prettier, and it just formats it on save. Actually, that might be for a different programming language. So this is the one that you'll have to use for Flutter, okay? And once you install it, you'll be able to auto format your code whenever you save your code, okay? So now we have this, but we do want to add a background to our splash screen. So we can add another parameter to our splash screen widget called gradient background. And this takes in a linear gradient widget. So we will do linear gradient. And in here, we do want to specify a couple parameters. The first one being begin. And this will begin at alignment.top center. It will end at alignment.bottom center. And this is just how we tell our widget where we want it to start and where we want it to end. And following that, we can pass in a colors parameter. And in this colors, we can list out the colors that we want in our gradient. So the first one will be a color from RGBO. Okay. And we will have a parentheses, and we'll do 138 for the first number, 35 for G, 135 for B, and for the opacity, we'll keep it full opacity, okay? And so once we have our first color, we can add another color. Actually, let's just copy paste this first color since it is the same code. So we'll copy and paste it. And for the second color, we want a R value of 233, a G value of 64, a B value of 87, and an opacity of 1. And let's add one more color, so we can put a comma, put another color widget, and in here we'll put 242, 113, and 33, and a opacity of 1. Now we do need to pass in one more parameter, and that parameter is the loader color, and this is going to be colors.white, okay? And so once we do that, we can go back to our main.dart file, and inside of our main.dart, we do want to return a material app. And in this material app, we want to specify a couple parameters. Now, the first parameter is the title, and this title will have a name of human generator. Following this parameter, we want to pass in the debug show check mode banner, which is this banner right here, and we want to set that to false. And finally, we want to set the home parameter equal to our my splash screen. And by doing this, it's going to redirect us to our my splash class that we created in splash screen.dart. Now we are getting this error, and the reason is because we need to import package human generator splash screen.dart. So once you import this, we should be able to use it. And so theoretically, if we hard restart our app, we should see our new splash screen. And so hot restart failed, so let's rerun our app. And I'm going to close this, so I can click this command prompt and press the trash can to close the split terminal. And I mean, you don't have to split the terminal, you can just create a new terminal by pressing this plus, and you'll have two different command prompts within Visual Studio Code. A very handy feature. So I'll let this load up, and once it's done, I will see you guys. Oh, very quick. We did not compile successfully. Now, no main method found. Okay. So to do that, we need to go at the top of our main.dart file, and we do need to specify a main function. And this main function is just going to take in run app, and it's going to take in our my app class. And this is just the first function that runs when we start our Flutter project. So we can do Flutter run, and that should take care of that error. So we'll let that do its thing. And as I said, we should redirect to our my splash screen. and we'll have a nice gradient with the title. Okay, so we're getting this error that our plugin file picker cannot be used. So right now, let's just get rid of it, and we'll add it later on. But for now, we don't need it, and we'll configure it properly in a bit. But let's rerun our project. But we do need to run flutter pub get, and once that happens, we'll run our project. And so I'll let it run, and I will see everyone once it's done. Okay, so my project has just built. Weird errors. Okay, and so now you can notice that we have our splash screen with face generator app and this nice loader. So now in the next app, or the next lecture, we're going to start working on our home.dart file. So I will see you there. All right, so let's start building out our home.dart file. And so the first thing I'm going to do is create a stateful widget. And so I'm going to put the shorthand STF, and I'll be able to run this Flutter stateful widget command and get the code for stateful widget. And so we're going to call this class home. And the first thing we need to do is import our material package. So we can do import m, and it's going to import this package for us. And once again, we do use the extension Flutter snippets in order to do those shorthands. And so now that we've done that, we can start working on our build method inside of our class. And this build method just holds all of the UI data. So in this build component, we want to return a scaffold widget, which allows us to properly just display information based off the scaffold. Okay. And so inside of the scaffold, we do want a stack because we will be stacking widgets on top of each other. We'll have a linear gradient, and on top of that linear gradient, we want our sketching pad. So that's what the stack widget is going to allow us to do. And so we can pass in the children's parameter, or children parameter, and the first child will be a container widget with a decoration of box decoration. And inside of this box decoration, we can specify a gradient parameter, and this is how we're going to display a linear gradient on our home screen. So this gradient parameter will be set to linear gradient widget, and inside of linear gradient, we will specify the same sort of parameters where we begin at alignment.top center. Now, if you wanted to start here and here, you would do left center, and so yeah, left top center, something like that. So I'm sure you'll get it. Following one is end, and this is where we end alignment, and this is going to be bottom center. So we start here, end here. Following that, we can add our colors parameter, and this is just the colors that are showing on our linear gradient. And we can just do this quickly by copying the splash screen colors because we do want the same background. So we'll go back to our home.dart and just paste these colors here. And I will add some commas after so we can properly reformat our code. And so now once we do that, we have a nice linear gradient on our background. So let's hot restart and go back to our splash screen. And in this navigate after seconds, we do want to specify our home widget, our home class that we just created, okay? And that won't work. So we do need to import it. Let's see if we can, might not be able to do it. All right, so let's go here, and we're just going to copy this import and go back here. And so we're importing package human generator, which is this entire project directory. And in here, we want to grab the home.dart file. And once we do that, we can hot restart our app, and it's going to load up our home.dart after this splash screen. Oh, so we have an error. And, oh, sorry about that. So I guess I changed it in the wrong. So let's undo that. Go back here to our splash screen. And, sorry about that, human generator. And now it should work. And we should also import, because we kind of screwed that up. We can do Dart. Actually, give me one moment. I'll just copy this, do that, and boom. Okay, cool. So let's hot restart the app. And what should happen is we load up this home class after 2 seconds. And that's exactly what happened. And so if you're not convinced that that happened, we can add a text. So inside this child, you can just do a text, and this text widget will hold text. And we can hot reload our app, and you should see text somewhere. Okay, we don't see text, but it's, yeah, you get the point. So now we're here. And so the following thing that we want to do is to start laying out the code for a sketchpad. And so that's what we're going to do in the next video, and I will see everyone there. Okay, so let's start building out our sketchpad functionality. And so after our container widget that we just created here, we're going to add another widget, and this widget will be the center widget. And the center widget will have a child of column. And inside of this column, we do want to specify the cross-axis alignment to cross-axis alignment.center. And we do want to specify the main axis alignment to main axis alignment.center. And that's just going to center our widget for us. And following that, we will add a children parameter so that we can put some more widgets or multiple widgets. And the first widget will have a padding, and it will have a padding of edge insets.all, and we'll specify 8. And within here, we do want to specify a child with a container. And this container will be the size of our sketchpad, and this will be 256 by a height of 256. And the reason we're doing that is because the images that get pre-processed into our neural network have this same size, so we do want 256 by 256. Now, if you do want to change this, we will have to change the dimensions of our neural network, which I will show you how to do. And so once we do that, we can continue building out our sketch functionality, at least the UI part of it, or the style part of it. And so after we specify the height and the width, we want to specify another parameter called decoration, and this decoration will take in box decoration as a widget, and in here we'll pass in border radius, and this border radius parameter will have a border radius widget all and a radius circular, and let me just check, I think it's 20. And so let's just put our commas so we can properly refactor this code. And once we do that, I'm going to save, and now it's all styled properly. And so far we've created this container with a height and width of 256, and we're adding some decoration to our container, which will have a border radius of 20, and that's going to give it a nice circular shape to it. And so the next thing we want to do is add a shadow. And in order to add a shadow, following this border radius parameter, we can do, let's see, where does it, okay, border radius. All right, I think right here. We can do box shadow, and this box shadow takes in a list, and in this list we want a box shadow widget, and this box shadow widget will have a parameter color, which is colors.black.width opacity 0.4. Following that, we will have a blur radius of 5.0 and a spread radius of 1. So once we do that, we've finished styling our sketchpad. And so in the next video, we will start building out our actual sketchpad so the user can draw on it. And so I will see you there. All right, so let's create the drawing functionality. And in order to do that, we do need to create a new file. So inside of our lib folder, let's create a new file called drawing area.dart. And in here, we want to import two dependencies, the first one being import Dart UI, and the following one, import material. So we can just do import m, and it's going to import our material.dart file. Now in this file, we want to create a class, and this is just a base class, and we will instantiate this class when we need it. And we're going to call this class drawing area. And in here, we'll have two variables. First one, offset, which is the point. The following one, the paint, which is the area paint. And so these two variables are going to allow us to properly put the data that the user draws onto the screen. So it'll make sense soon. But the first thing we're going to do is whenever someone instantiates this drawing area class, we will set our two variables here to what the user passes in. So we can do this dot point and this dot area paint. And so whenever someone calls this class, they can pass in two variables, point and area paint, and we're going to store those variables within these two here. Okay. So now let's start creating our actual painter class. So we can do class my custom painter extends custom painter. Oh, whoa. All right. And so, okay, so we need to pass in these two parameters, and this extension here, custom painter, is what allows us to draw on a widget. Okay. So this is a very handy tool for our functionality that we're using in this app. And so the first thing we can do is pass in, actually, should we, yeah, let's first put in void paint, which is the required method within this custom painter class. Since we are extending it, we do need to pass in two required methods. So the first one is paint, and in here we're passing in a canvas with the name of canvas and a size called size. And the following class is should repaint. And so for this function, we will do bool should repaint my custom painter old delegate. Now you don't need to understand what's going on here. This is just the algorithm that allows us to draw on a container. So we'll do old delegate dot points does not equal points, and this is just a important point. Sorry, old delegate dot points does not equal points. Okay, so we're going to create it here. Okay, so let's create a list, and this list will be a type, will hold data of drawing area type, and we'll call it points. And so this list is going to hold all of the points that the user draws on the sketchpad. Now you can think of a point as a XY coordinate on the sketchpad, and that's what's being stored inside of this list. And this points list is just going to hold all of the data points that the user drew onto our sketchpad. Okay, so essentially this is the painting, or this is the sketch that the user drew, and this is the variable that's going to hold that. And let's pass in a constructor. Now this constructor will be my custom painter, and when we call our my custom painter class, we are going to pass in a list of drawing area points. And as I mentioned, this is the list that holds our sketch, and we do want to make this required. And so we're going to get this list of points from the user, and inside of our class we can go to this paint function, and we can start adding the required variables. So the first thing we're going to do is add a paint background, and this will be equal to our paint widget, and this paint widget will have a color equal to colors.black, and we're using this notation here with the dot dot to set a parameter within this widget very quickly in one line of code. So we're adding the background to black. Next, we can add a rectangle, and this rect will hold the boundaries of our sketchpad. So we can do rect equals rect dot from LTWH from left top width height. So we want it from the zeroth index, 0 coordinate, so right here. And we want our sketchpad to go 256 by 256, right? So we can do size dot width, and we can also do size dot height, since we do pass in our size here, okay? And we're gonna set this rect variable to our boundary sketchpad, okay? Now the following variable that we'll set is canvas draw rect, and actually draw rect, and we're going to pass in rect with our background, and that's just going to print out our rectangle. And finally we'll do canvas clip our rect, or clip rect, just clip rect, 1R, and we'll pass in our rect variable from above. So now for the algorithm that our paint method is going to use, we're going to use a for loop. So as I mentioned, this is the functionality that's going to allow us to draw on the sketchpad. So it's not important to know this, it's just important to see the functionality on how you can draw on a sketchpad. So just follow what I do. So first I'm creating a variable x equal to 0, and we're iterating until points.length -1, since we do start at 0, and we'll increment x every time we iterate in this for loop. Now inside of this for loop we do want a if statement, and this if statement will check if points x does not equal null and points x plus 1. So if the current point does not equal null and the following point does not equal null, then what do we want to do? Well, we want to canvas draw line, and we're going to pass in points x dot point. And for the next parameter inside this draw line, give me one moment, let me just, all right, that's fine. So for the next parameter, we can do points x plus 1 dot point, okay? And the last parameter is point, oh my god, sorry. All right, points x, and we'll pass in area paint. Awesome. So now we will have another logical statement, else if, and in here we're going to check points x does not equal null and points x plus 1 equals null. Then we want to do canvas dot draw points, and we'll take in our point mode dot points. Did I write that? Expected to find, okay, sorry, fine. And so in here we need to pass in a list, which will take in points x dot point, and following this we will have points x dot area paint, okay? And let's put our semicolon at the end, and we are getting one more error. A function body must be provided. So let's pass in, I think we need to override it, so we can do override. And once we do that, we do need to add an override method to our should repaint. And so we are missing our semicolon here. All right, cool. So now we've built all the functionality to draw, and so now we need to display it. And displaying the sketchpad. Okay, so that's what we're going to do in the next lecture, and so I will see you there. Now, there's one thing that I forgot to do, and after our round bracket here, we do need to add a colon, and this colon will have this dot points, which will be equal to points dot to list. And this is just necessary for the latest version of my custom painter. And so by adding this, we should have a working sketchpad. Okay, now in the previous lecture, we created the class that's going to allow us to display a sketchpad and allow the user to draw on it. So now we need to call our class inside of our home.dart. And as you notice here, we do have this box shadow. And so on top of this box shadow, we do want to add another widget. So following this box decoration, let's add a child parameter, and this child parameter will take in a gesture detector. And the reason we're doing a gesture detector is because whenever the user presses something in this vicinity, we do want to do something. So the first thing that we're going to do inside of this gesture detector is pass in the on pen down method, and this is going to be equal to details, which is going to be a callback function. And so on pen down, whenever the user goes down, what do we want? Well, we want to set this dot set state, and we want to add a points to our list. We want to add points to our list, and we're going to add drawing area. And inside of this drawing area, what do we want? Well, we want to pass in our point, which will be details.local position. So that's where the user pressed. So we're storing it in this point. Following that, we will have an area paint, and this will be set to the paint widget, and we can set a couple of parameters for our paint. So the first one will be stroke cap, and this will be equal to stroke cap. Oh, give me one moment. Stroke cap. Dot round, and we can add two more dots for another parameter, and we'll add the is anti-alias, and we'll set this to true. Following this, we will add another parameter, color, and this is colors.white, so this is going to be the color of our pen in our sketchpad. And finally, the stroke width of our pen will be 2.0. And so we can add that. And so now we have two errors. Now the first error is this points.add. So we don't have this points variable. So we do need to create a variable that's going to hold all of the points that the user draws. And this drawing area is this class that we created here, and we're passing in a point and area paint, which we specified here. And this area paint is just the properties of our sketchpad. So let's fix that. So the first thing we need to do is create a variable called points. So let's go to the top, and under our state class, let's create a new variable, list drawing area. It's a list of drawing area called points, which is an empty list. Okay, and so that's going to solve our error where we did not declare points. And the following error is this drawing area. So we can import, and we'll import package human generator, and in here we want to import the drawing area file. And so once we do that, we can hot restart our app. We'll see our splash screen, and so right now there's nothing there, but eventually we should see a black canvas that we can draw on. And so we'll pause here, and in the next video we'll keep going on our sketchpad, and so I will see you there. Alright, so let's continue our drawing area, our gesture detector here, and let's add some commas so we can properly distinguish the different widgets. And so once we do that, we want to add another method in this gesture detector following the on pan down. So I like to press this curly bracket and it indicates where it ends. So we're just going to copy this and paste it because we're going to do, instead of on pan down, what we want is on pan update. And we do want one more, so we can paste it. And it is the exact same code, so you can just leave it. And so the last one will be on pan end, and this is when the user lifts up their cursor or their finger. And so we don't want to add a point. What we want is to get rid of this. And what we want is to do points dot add null. So we want to add null points. Okay. So when we lift up, oh, what happened here? All right, let's copy this. This needs to be on pan update. I don't know what happened there. I'm sure you guys saw it, but all right. So now we have all three cases of the user drawing. We have the first one on pan down when the user draws, on pan update. So whenever they draw upwards, downwards, sideways, we want to also add it. And then when the user lifts up their finger, we are going to add nothing to our list. Okay. So once we do that, we can start filling out this container so that we can draw on it. And so following our on pan end inside of our gesture detector, we do want to add a child, and this child will have a size box of dot expand. And inside of this expand, we want another child of clip r rect. And in here, we do want a border radius. And we want the clip r rect because that's what's going to allow us to add border radius to the following widget, as you'll notice. So we'll set the border radius to border radius dot all, and so we'll pass in radius dot circular of 20, and that's going to give us a nice round shape with 20 pixels on each corner. Now, following this border radius parameter, we do want to add a child, and this is the last function. So we'll do custom paint, and in here we want to pass in our painter parameter, and that's going to be my custom painter. And so we'll pass in points with the points list. And now let's hot restart our app, and what should happen is we should have the functionality to draw. And so that's exactly what happened. Now, it's not important to understand how this algorithm here works with the for loop. It's just the algorithm used to draw. But if you want to understand it, it's not too complicated. You just, it's just, if this current point is not equal to null and the next one's not equal to null, then we want to draw a line. And so if the following one is null and this one's not null, then let's draw a point. Okay, so it's very simple. And as you can see, we have all the functionality that we want. And so in the next video, we will add some more functionality where we can clear out our canvas so that we can restart a painting. And by doing that, we've pretty well done most of the functionality for our mobile application, and we can start moving on to building out our neural network in Python. And so that's very exciting. And so I hope I will see everyone there. Okay, so let's give the user the functionality to clear out our canvas. And so we'll go back to our home.dart file, and inside of our home.dart file, we want to add a new widget, and this widget will be after this padding widget that we created, okay? And this is still inside of our column widget. So after our padding widget, let's create a container. And this container will have a width of media query.of context. So this is going to get our media query.of will get our size of the screen. So we can do dot size, and then whether we want height or width, we can just specify it here. So we'll get the width of the screen. And so this is for responsive design. And so we'll multiply that by 80 so that we take 80% of the width through this container, okay? And this container will have a decoration set to box decoration. And in our box decoration, we want a color of colors.white, and we want a border radius of border radius.all, and we want a radius.circular of 20, and that's going to give us a nice circular shape to our container. And once we do that, we can add a child to our container, and this child will be a row. Okay, and inside of this row, we do want to set the main axis alignment to main axis alignment dot center, and that's just going to center it within the row. And in here, let's put the children, and the first child, and the first and only child, will be an icon button, and this icon button will have an icon of icons layers clear. That's just the one I chose for this case, and the color of it will be colors.black. And so when the user presses this, we do want to set the onPress. So following our icon widget here, we want an onPressed method, and this will be a callback function. So we'll put a round bracket followed by a curly bracket, and inside of the curly bracket, we do want to change the state of our app. So we do need to specify this.state, and in here, just press enter there so we can get the proper syntax for it. And so here we can do points.clear, and that's it. So let's hot restart our app, and so we'll have a button with this layers clear icon. Oh, okay, so we lost connection. So let's rerun our project. And so we should have a row with a main axis alignment of center, so everything in this row will be centered. And the first child will be an icon button with a clear icon and a type of clear with a black color. And when the user presses it, we just clear our list of points. Okay. Now I keep getting this, and the reason is because my memory on my storage is low, just so I can keep the storage low on my computer. So you don't have to worry about that. I'm sure you guys won't see this error, but for me, it's just how I set up my emulator. And so now when I draw something on this canvas, I should be able to clear it, and that's exactly what happens, because when we click this button, we are clearing or deleting all of the memory or data inside of this list. Okay, so very simply, we just have a list which holds all of these data points, and when we press this, it clears it. Awesome. So now we've completed the functionality of our application. And so the next thing we're going to do is to build out our neural network. And so the algorithm that we're going to use is the Pix2Pix algorithm, and I will go into depth. And I do plan on going over the research paper of Pix2Pix so that you guys can get a better understanding, and you guys will understand how to read a research paper for one of these algorithms so that you can use it for any algorithm that you want. So that's very exciting, and I hope you guys are very excited about it because it's a very cool algorithm. And I was talking to one of my friends, and he did mention that this app would be a very good app for police officers who, receive a sketch of a human being, and using this algorithm Pix2Pix, we can generate a realistic image of that sketch of the suspect or the person that we're looking for. So it's a very handy tool, and it's a very powerful algorithm, and it's one of the state-of-the-art algorithms in artificial intelligence. So yeah, I hope you guys are excited, and I am excited to keep going. So I'll see you guys in the next video. All right, so let's start building out the neural network for our mobile application. Now, the first thing that we're going to do is go onto Google, and we're going to search up the algorithm that we're going to use in this course. So we're going to search up Pix2Pix, and we're going to append TensorFlow after that. Now, we're going to search this up, and you'll notice that there's this TensorFlow core webpage with Pix2Pix. Now, this is the link that we want to click, so I'm going to click it. And once you click it, you'll notice that there is this documentation page for TensorFlow. And TensorFlow is a package made by Google, which allows developers to build neural networks very easily. And on top of TensorFlow, there is this package called Keras, and it's just a very easy package to use to build neural networks. And I do recommend it to learn it if you are unfamiliar with it. It's a good introduction to building neural networks. But for this case, we're going to use the generative column or category, and inside of here, we're using the Pix2Pix algorithm. Now, once you're in this Pix2Pix algorithm page or documentation page, you can click this Run in Google Colab. Now, what Google Colab is it allows you to run Python scripts in the browser. So instead of having to download Python and going through the entire process of installing the dependencies for this project and doing all those sorts of things, you can just click this button and start running Python code immediately. So as you can see, we're importing TensorFlow and other libraries, and I can use Shift and Enter, and it's going to run this code block. See? And once you see a number here, that means the code block has been ran, and we're ready to go. So in this algorithm, we are creating a mapping between this input image and this building. So the Pix2Pix algorithm is essentially a mapping of one input image to an output image, and our AI is essentially learning the patterns of this input image and the associated ground truth. Okay, and over training, it's going to learn what it's supposed to predict based off the input image. So as you can see, after 200 epochs, this is what we got. We have an input image, and we predicted this image here. So it's a very cool algorithm, and it uses a conditional adversarial neural network. So if you want to learn more about it, you can click this paper and view it here by clicking this PDF, and you'll see the entire research paper on this algorithm. Following this, let's walk through this code for this Pix2Pix algorithm, and in the next video, the next lecture, we'll start building out our own algorithm for the human generator. Now, in this case, we import TensorFlow, which allows us to build our neural network. Following that, we pip install TensorBoard, which allows us to view how our model is doing while it's training. And then we load our dataset. Now, it's important to note that for this dataset, we are importing it from a URL. Now, in our case, we will be downloading the dataset and importing it into Google Colab. So we will be using a different strategy. But here they grab a URL, and from this URL, we get the file using this tf.keras.utils function. And then we add it to our path so that once this is done, we can go to our directory here, refresh. Okay, all right, we'll let that finish. But once it's finished, we should see a facades folder, okay? And here we have, it seems like it's done, but it's not showing up. Maybe it's stored in memory, okay? It's probably stored in memory. But in the next case, we'll see that. We'll see it here, okay? So here we have our hyperparameters. So we have our buffer size, our batch size, image width, image height, and we want to keep these at 256 because this is what we set in our Flutter application, and we do want to have the same values to pass in from our Flutter application to our Python neural network. So we'll keep these as 256 by 256. But if you do want to change it, you can just change it here and inside of the Flutter code. The batch size is just how many images we're inputting into the neural network. Normally 1, 4, or 8 are good numbers for this. But for this case, let's keep it at 1. I'm going to shift and enter. Next, we have this load function. And here we're reading a file, image file, decoding it, and we're grabbing this following code. It's important to note that oh, give me one moment. That so here we are grabbing the shape of our image, and it's, as I said, it's important to note that the images that we're receiving from this data set are images similar to this one. So we have our real input, or real image, and the sketch of this image, okay? And essentially we need to break up this image since they are concatenated together. So what we're going to do is we're going to create this variable called w, and this w will be set equal to the entire width of this image. And so we're going to divide w by 2, and so we're going to get this width cut into half. So now we have our w, which represents this side and this side. So our real input image will be everything to w, and our input image will be everything after w. Okay? And so by doing that, we are essentially splitting our two images. So we can run this, and then we're returning our input image and our real image. So here we are calling our load function with our path that we created here, and our train image, which is just an image in the data set here. So let's run that. And we should see our two images split, although we are not using the human data set, so for this case we're using the facades. Okay, so here we have several pre-processing functions, so a resize function, a random crop function, a normalize function, random jitter function. Now these aren't super important, they're just used as helper functions for our model. Now let's keep running this project. And so we ran this random jitter function, and it simply just jitters the photos. It's not super helpful, but for this case, Google's developer team did create it. Next, we create these functions to load our training set and our test set. And now we have our training data set that we're creating, and we are creating our test data set. And let's run that. And by running these two pieces of code, we are essentially creating our training data set for our model, and we are creating a test data set for our model. So we have this map function. It's not super important, but we're just mapping each image to this auto tune. And then we're shuffling our data set so that it's mixed up. And finally, we're creating a batch size. So these are just changing up the data set. And we're doing the same thing for the test data set for our model. And following that, we start building out our generator. And the generator is composed of these downsamples and upsamples. And so in each of the downsamples and upsamples, we're creating a sequential layer. And in this sequential layer, we have a convolutional layer with these associated filters, size, and if batch normalization is set to true, we're going to go here. And finally, we're going to put a leaky relu. Now, this is for the downsample, and for the upsample, we are using a convolutional 2D transpose, and this is going to create a bigger output size. And the reason we want a bigger output size through each layer is because we want to upsample the image. And what that means is we want to generate our image. Okay, so this is what's going to generate it. This is what's going to allow us to understand what's in the image. Okay, and so if you see this definition generator, we are essentially composing our generator of these downsamples and upsamples. Okay, and we create a layer through these, and yeah. So we can continue running these code blocks. I think I missed a couple, so let's go up here and run these. Okay. And so here you can see the entire layer. And all right, so here we've generated our first output with our generator, and as you can see, it's doing a very poor job of generating our output. And in order to make it better, we do need to train it. So that's what we'll do in the following steps. But before we do that, we are going to specify a generator loss function. And if you're familiar with what machine learning is, a loss function is what allows us to see how our model is doing through each iteration step. So it's essentially a function that allows us to see how far our model was off in its prediction, and then we can adjust the model's weights based off that loss. Okay. Now we created the discriminator, and the discriminator's job is to tell whether a generated image is fake or not, and you can tell by the output here. And let's just see. Yeah, it's very similar to the generator. We do downsample and we have zero padding. It's not super important to know these different layers. All you need to know is that the generator is generating an image and the discriminator is telling whether that generated image is fake or not. And it's in this continuous training loop that we create a very powerful generator. So you can tell that there's this adversary of two neural networks that compete with each other until the generator can fool the discriminator successfully. All right, so let's keep running these code blocks. And here we're instantiating our discriminator function in this discriminator. Next, we're outputting our discriminator output, and you'll notice that there's no output, and we do need to train it. Next, we're doing the loss, and this is just for machine learning purposes, so we can allow our algorithm to learn. And here we're just looking at the model and the optimizer functions. These are essential to training our model. This is the learning rate, and this is the beta. If you're unfamiliar with what these terms are called, I would recommend looking it up. Next, we're setting up a checkpoint so that we save our model whenever we pass a certain amount of iterations. So let's run this. And finally, we're creating a function that allows us to generate our image based off the generator model that we pass in, and a test input, and it's going to plot our data out in a very nice way. So we can run that, and we can run this code here, and you'll notice we have our input image, the ground truth, which is what we should have predicted, and this is what we predicted based off the generator that we have so far. So now we're ready to train our model, and to train our model we can set the epochs here, and the epochs is just how many times we're going to iterate over the data set in our training phase. Okay, so we can run this with 150, and we'll run all these other code blocks. So train step, so every time we train we're going to run this, and we're going to compute the gradients and the loss functions, and then we want to create this fit function, which is what we're going to use to train our model right here. So let's run that, and through each fitting epoch we are printing out a generated image, and then this is our training loop. So in our training loop we call train step, and then in every 20 epochs we want to save our file. And so we can run TensorBoard, but I don't really want to run it right now. Feel free to run it. But after that, we can fit our model. And once we fit our model, you'll start to notice that we're training it with these dots. And you can see that it's going really fast. So that's really cool. And it's going to do that for 150 iterations. Now, you can leave it on. I'm just walking through this code, so it's not important to keep it training. But for your fun, if you do want to train it, feel free. But for this case, we won't. But this concludes this code. Now in the next lecture, we are going to actually build out our human generator. And we're going to use a lot of this code, and we're just going to change a couple things. The only thing we're going to change is the data set that we're inputting into the neural network. And so, sorry about my cat, he's a little baby. But yeah, so in the next lecture, we will start building out the human generator. I will see everyone there. All right, so let's start building out our neural network. Now, the first thing I'm going to do is go into Google Colab, and on Google Colab, when we search it up, we can click this first link, and let's create a new notebook. Now, once we create a new notebook, we will have our brand new Colab free to use. So, for example, we can do import TensorFlow as TF. And that should import it. Awesome. And you can press Shift and Enter at the same time to run a code block. And on top of that, let's change our runtime. So we can go to runtime here, change runtime type, and here let's use a GPU. And this is just going to make our code run a lot faster, especially for our computation phase where we're training our model. When you train a model, there's a lot of computation going on, so it's a lot better to use a GPU for that sake. When you use a CPU, it's a lot slower since your CPU can handle a lot less computation than a GPU. But now we're ready to go. And so what I'm going to do is I'm going to upload a notebook. Now, in this associated lecture, you will find the notebook that we'll be using. So you can click Upload Notebook, and I'm going to click Upload, choose File, and I'm going to choose the file that you guys should download. And you'll see that it uploads, and there's a success, and awesome. So once it's done, you'll notice that we have very similar code, although we do have various different things. So we do have this unzip here, and that's just for unzipping the zip file that we upload. And so we still have this load function. We have this, but with a different image. And we have resize, all our pre-processing functions here, and everything else is very similar to the last model that we created. We do have this here. I will explain it in a bit. But for now, let's get the data set. Now, for the data set, there's this very cool and handy website called Generated Photos. Okay, and here you'll notice that there are a lot of good high quality images. Okay, so it's a very good website for building these sorts of human generators, human classifiers, or any sort of model that uses human faces. Now we can go to the pricing section here and click the free section, and you can start your trial here and sign in, and yeah, but once you sign in, you can start downloading some images. Now I've already pre-processed the data set for you guys, so you don't need to go through these data sets and download each individual image. You will also find an associated URL to my Dropbox, and you can download the pre-processed data set with the outline next to it. So do download the data set as well as the notebook. And so once we do that, make sure you sign in and create an account on this website. I do want to give proper credit to this website. It's a very handy website. And we wouldn't be able to create a very good human generator if it wasn't for this website. Now, once we do that, we can upload our allhumans.zip file that we downloaded. So to do that, let me manage, and let's terminate this one, and let's, all right, maybe that should work. Let's see. All right, it's working. Okay, so I'm going to upload my two folders. So the first one is the all humans. So just give me one moment. And I'm just going to drag and drop these zip files. So there's this all human zip file, and you can notice the loading icon here. And there's also a test zip file, and this is the test data set that we'll be using. So I'm going to let this download, and once it's done downloading, I will see everyone. Okay, so my data set's about to finish, and it does take a while since there are quite a bit of photos. But once it's done, we can start running our code. So let's run the first code block, and that should run. And let's run this other code block, which unzips our zip file. So let's run that, and you'll notice that we unzip every single file. Let's do the same for the .zip, and so we can refresh this, and you'll notice that we now have 2 folders with our data. And so here we have our hyperparameters. I did change the batch size to 8. Feel free to tweak it to 4 or 1 to see differences in the training phase. Next, we are creating a variable that stores our all humans path, so we can do that. And I went over all this code in the last lecture. If you want to understand this, do watch that video. So let's continue, and here we're loading our image. My cat's also a machine learning engineer, so when he meows, it's for extra help. So now we have our pre-processing functions here with resize, normalize, and random jitter. Just functions, and our load image train, our load image test. We're creating our train data set, very similar to the last notebook. We have our test data set, the output channels, which is RGB. Next, our downsample, which I explained in the last lecture, so we can just skip through that. We have our generator function, which creates our generator. Now in this code block, let's say we've trained our model overnight. What we want to do to load up that trained model so that we can continue training it is we can comment out this generator function, because we are creating a new instance of this generator, and we can uncomment this code. And so we're loading this model and setting it equal to generator. And so when we do that, we can start making out predictions based off this neural network that we trained. So very cool. But for this case, for the first case, we're going to create a new generator. And so you can see the output is very poor right now. This lambda is, it's not important, it's just part of the loss function. And so let's keep running our code blocks. And I didn't talk about the discriminator in the last video. The entire job is to tell whether the input image that we receive is fake or not. So that's the entire job of the discriminator. We can continue running this, and we create our loss functions, which allow us our model to learn. And here we have our learning rate and our beta. If you want to learn more about that, do make sure you search it up. Next, we have our checkpoint directory. So we're saving our model every time we do 20 iterations. As you'll notice in the following code, generate images. This is the function that allows us to print this out. We take our generator and our test input, and we create a prediction. So we can keep going. Here we can change this to whatever we like. Let's change it to 150. And let's continue. Okay, and here, oh, this needs to be commented out. Sorry about that. So do make sure you comment that out. And once we do that, we've successfully created the function for our fit, and we can start training our model. So once we start training our model, you'll notice that we have a very poor prediction so far. Through predicting and training, our model is going to become very better, for very good. And yeah, so now it's just about letting your computer train. And so I'll see you guys once this is done. I will stop this early. I'm I'm not going to do the full 150 since I've already trained a neural network actually. So I'm just going to change this to 1. So let's stop this code block from running. Go to epochs, shift enter. This is just for me. I've already created my model. But for now, let's just change that. As you can see, we've trained our model and we stopped it. So our generator has updated its own weights. So you can stop it whenever you want, and it's going to save the latest weights. And yeah, so it's very cool. Notebook. So I'll let this do its 1 epoch, and once it's done, I will see everyone. Okay, so my model has just finished the 1 epoch, and so you'll see this time taken for 1 epoch here. And if you did more than 1 epoch, you'll notice that it continues training and it continues making this nice generated image thing. And once we do that, we can save our model in this .h5 format. And once we run this code, you'll notice that we now have a test.h5 folder or file, and we can easily just download it as so. And now we have our model on our local computer. And this is what we're going to use to make predictions from our Flutter application. Now, in this following code block, you can test it on your own images. Now, I do have this image right here, test.png. I just dragged and dropped it. And it's a very stupid and very easy human drawing. As you can see, there's an outline. So I like to test on it just to see how our model's doing for a very simple human sketch. So it's doing already pretty good. It already looks really dumb. But yeah, it looks really cool. And we can use this other function, which is the generate image function. And it just generates our image based off our generator and the test dataset that we passed in earlier. And so we're just testing it on the test dataset, and the test dataset is just the images that our model has yet to see. So for sketches that our model has yet to see, it's still doing a pretty good job, especially after 1 epoch. So we definitely have a good model so far, but we do need to train it some more, and I hope you guys train it some more. I will be giving you guys access to a fully trained model, so you guys can use that if you don't want to train, but training a neural network is always fun. But once we do that, we're ready to build our API and continue our Flutter application. So in the next lecture, we will start building out the API that our Flutter application will interact with to make predictions. All right, so let's start building out our Flask server. Now, if you're unfamiliar with what Flask is, it essentially allows you to build a REST API. So in a Flask server, you can either post data to it, which is sending data, or you can get data, which is just receiving data from the server. So when we create a Flask server, we're essentially creating a server that we can call to from a different application, such as our Flutter application, and we can call to the server. We can send data, so we can send the human sketch, and we can use some computation on that sketch and generate a new image and post that data back to the user. Okay, so it's essentially a Python server where we can do computation and send information back to another client or another programming language. Okay. So the first thing I'm going to do is make dir, and this make dir, we'll call it Flask server human. And let's cd into this new folder. And once we're in here, I'm going to run code dot. And what code dot does is it opens Visual Studio Code in the directory that I'm in command prompt. So it's a very handy tool. You do need to have Visual Studio Code added to your path in order to do that. But if that doesn't work, just open up your preferred coding editor and open up the directory. And so once we do that, we can create a new file, and this file can be called humanflask.py. Okay, and this is a Python file. So you do need to make sure you have Python installed on your computer, and it should be in your environmental path so that you can use Python. But once we do that, we can start importing the required dependencies. So the first one let's do is keras.model, and from here let's import load model. Now the reason we want that is because we want to let's go down to line 5, and let's create a model variable. Okay, and this model variable will be equal to load model, and inside the load model let's pass in the model that we created. So for this case it was test.h5, and I'm going to just drag and drop my test.h5 model in the same directory so that we can load the model accordingly. Now after we do that, I do want to print model loaded, and this will just be a way for us to tell whether our model has been successfully loaded. Alright, so now let's create the Flask server. Now for the Flask server, we do need to pip install some packages. You also do need to make sure you pip install keras. But once we do that, we can do from Flask import Flask, and we want to import Flask, we want to import JSONify, and we also want to import request. But once we do that, what we can do is we can create our new Flask instance, and we can do app equals Flask, and in here we want to pass in underscore underscore name underscore underscore, and this line of code is going to create our Flask server. It's going to instantiate our Flask server, and we also need to pass in API equals API app, and this is going to create the API for our app. So this is just the basic process of creating a Flask server. So once we do that, we can create the class. So the class is going to be called predict, and in here we're going to pass in resource. And so in this class we want to create a function called post, and this is going to allow us to post data or send data to our server, and the data that we want to send is a byte representation of the sketch. Now if you know anything of an image, is that every image can be composed of this base 64 encoding. Now we can encode and decode images and keep their structure through this base 64. Now this is what we're going to be sending between our Python and our Flutter application. We're going to convert our sketch into base 64 inside Flutter. We're going to send it to our Python script. We're going to decode the image inside of our Python script. We're going to pass in that decoded base 64 image into our model. We're going to make a prediction, our generated image. We're going to decode the generated image and then send that base 64 encoded string to our Flutter application, and we're going to decode it once more inside Flutter, and we're going to show it. So the base 64 string is how we're going to pass data between our server. And that base 64 is our image. It's an encoding that represents our image, and this encoding can represent any image on the internet. So it's important to know that. So in this post, let's create this JSON data variable, and this is going to be set equal to request.getJSON. And essentially what this is doing is we're receiving JSON data, and it is through JSON data that you send information between programming languages. So we do need to get the JSON that we send from our Flutter application, and now this variable JSON data is now holding the data that our Flutter application sent. And so what we can do now is we can now if you're familiar with JSON data, everything is represented by key string pairs as so. Okay, now the JSON data that we'll send from our Flutter application will have a key of image and a base base64 string here. And so what we want is this base64 image string. We don't want this entire JSON data. So we need a way to access just this string. Now, in order to do that, let's create a new variable called image data. And this image data will be equal to JSON data, and we're going to extract the image key. And by doing that, we are setting the image key value to image data. So now this image data is holding our base64 of the human sketch. So now we can do image equals base64 b64 decode, and we can pass in the string of our image data. Okay, so we do want to typecast it to string just in case it's not a string. And so this is going to decode our image. So this image variable now represents our actual image. And this image is what we can pass into our neural network. But if you do remember, in our neural network, we pre-process the image so that it can fit properly for our model. Now, if we do try to run this, it won't work because we do need to import a dependency. And that dependency is import base64. Awesome. So once we do that, what we can do is, well, we have our image. So now we want to actually create an image of this base64. So we can do image equals image.open, and we'll do io.bytes, io, capital IO, and pass in our image. And this is going to actually create our image. So now, I think we might need to import. Yeah, so let's import IO. Okay, ooh, I don't want that open. All right, and that's going to allow us to convert it. Awesome. So now we need to prepare our image. So to prepare our image, let's create a function above, and we'll call it prepare image. And in here, we'll pass in an image and a target. Target spelled with a T, and our colon. And in here, well, we want to check a couple things. Now, the first thing we'd like to check is if our image is RGB. So to do that, we can do if image.mode does not equal RGB. Well, what do we want to do? Well, we want to convert it to RGB. So we can do image equals image.convert, very simply, and RGB. Beautiful. And once we do that, we've converted our image to RGB. And so the next thing we can do is resize our image. So we'll do image equals image.target. And in here, let's pass in target, or no, sorry, image.resize, and that's going to resize the image to 256 by 256, or whatever value we pass in for target. Next, we want to convert this image to an array so that we can have a representation of the image in numbers. So to do that, we do need to import another package, and this is from keras .pre-processing image import image to array. And this is just going to convert our image to an array, very simply. And so what we can do is we can do image equals image to array, and we can pass in our image. So now we have an array representation of our image, and now we need to pre-process the image similar to what we did in our notebook. But in this case, we're just going to divide it by 127.5. So we can do image equals, and round bracket, so image minus 127.5, and let's divide this by 127.5. And this is just going to normalize it in between, I think, -1 and 1. And that's just going to allow our neural network to pre-process the data or train on the data a lot quicker. So, and finally, we do want to expand the dimensions to image. So image equals np.expand dims, and here we'll pass an image, and axis equals 0. Now we don't have this np package, so we do need to import numpy. So we can do import numpy as np. Oops. And so I'll save that, and now we can finally return our preprocessed image. And we may have an error, but in the next video we will continue building out our Flask server, and we'll continue building out our post method here. And so yeah, we'll make our prediction on this image, and we are going to process it accordingly. Now I'll see you in the next lecture. Okay, so we have our image here, and we just finished the prepare image function in the last lecture. So what we can do is we can prepare our image. So we can do prepared image equals prepare image, the function that we created above, and we'll pass in our image, and we'll set target equal to a tuple 256 by 256. And so this is going to take in our image here and change our size to 256 by 256 in the case that it's not 256 by 256. So we have our prepared image, and now we're ready to make our prediction. So we can do preds equals model.predict, and in here let's pass in our prepared image very simply. And so now this preds is our generated image. Very cool, very cool. So here we've sent data, JSON data, and in this JSON data we have a base 64 encoding of our image sketch, and so we are decoding it. We're preparing the image to be 256 by 256. We're normalizing it, and so next we are predicting on this image. Very cool. So now we need a way to send back the data. Now, my solution to this is I saved this preds folder, or this file, inside of a folder called output. So let's create a new folder called output. And so we save this preds variable into output. So let's do that. But before we do that, we do need to set a couple parameters, and we do need to import a couple libraries. So a first library that we'll need, let's make some space since we are working on a different part. Let's import time. Let's import from keras.preprocessing.image import save image, and that should be good for now. So we're just importing this time library, which tells us the time, and the save image library, which allows us to save the image. So here, after our prediction, we can create this variable called, actually we don't need time, sorry about that. Let's create a variable called output file and set it to a string output.png, and this is just the output file that we're going to put in output. And then we also want a save path variable, and the save path variable will be equal to our output folder. So here we can do dash output to get this output folder, and then dash, and that's going to get us to this directory. So now we do need to reshape our predicted image similar to what we did in our notebook. So let's go here. Okay, I might not find it. I think this. And generate image. Okay. No, I can't find it. All right. So let's go back to our Visual Studio Code. But pretty much we do need to import another library, and that library is import TensorFlow as TF. And in TF, we do need to reshape our data. So we can do TF.reshape, and we need to reshape it into, so we'll pass in pres, and this is the variable that we want to reshape. And we want to reshape it to 256 by 256 by 3. And this is the standard shape of an image. So this is what we want to keep it here. Now we do want to store this reshaped prediction in this output variable. And yeah, so once we do that, we do want to renormalize our image, or unnormalize it, so that we can save it properly. So to do that, we can do output equals round bracket output plus 1 divided by 2. And then we can save our image. So we can do save image, pass in our save path plus our output file, and we're going to store our image to array output. And this is going to save our output in this output directory. Cool. Oh, output. Awesome. So now we have our file saved in this output directory. So what we want to do now is open this image. Now this is the solution, as I said before, that I found for our Flask server. It seems, I'm sure there's a different way to do it, although this is the solution that I found, and this is what worked for me, and this is what allowed me to build a scalable machine learning model for our case. So it is pretty iterative, and seems like there's a lot of unnecessary code, but this is the solution that I found. Okay, so let's go here and create a new variable called image new, and this is going to be image.open, and we're going to open save path plus output file. So we're simply just opening up the image we just saved. And now let's resize this image. Now the reason we're resizing it, I'll show you later on when we start interacting with our Flask server. But we want to resize it to 50 by 50 because we can't send too much data through our Flask server. So we do need to resize it so we can compress the data. And so I'm going to do image new dot save, and we're going to save this new resized image. Okay, so we'll do image new dot save, save path plus a string new underscore plus output file. Okay, and so we're saving our new image with a new prepended tag. Okay, so now we have two files in our output directory when we interact with our Flask server. First one, output.png, the other one, new output.png, and this new output.png is simply an image, the same image, but resized to 50 by 50 so that we can send our data in a compressed manner. Now, once we do that, we can do with open, and now we want to open up our saved image new image. So we can do with open save path plus new underscore, and we're just opening up our output file from above, and let's read it as binary, and we're going to do it as image file. So our image file is our image. Okay, so what we can do here is we can do encoded string, and we're converting it into base64. Now we're converting our image file to base64, so we can do encoded string equals base64 dot b64 encode, so very similar to the function here, but this time encode image file dot read with round brackets so that we can properly read the data of our image file. So now our encoded string is our base64 of the generated image. So now what we can do is we can send our data back. Awesome. So we can create a JSON data thing here, sort of like a dictionary. And here we want a key value pair, and the key is image, and the value is a string of our encoded string. Okay, so we're just typecasting it to string so that we make sure this encoded string is string, and this is just for scalability purposes. So now we have our output data, which is JSON of an image and our encoded string. So now we're sending back JSON data. So we can just simply return output data. Awesome. So now we may have a couple errors because we are missing a couple packages. So let's import a couple. So first one is this image here. So for that, we do need to import this package called pillow. Now, if you don't have it, do pip install pillow. But when you import it into your code, it's just PIL. And we can do from PIL import capital image. And next, we do need to add this other package called Flask RESTful import resource API and rec parse. And this is going to allow us to create a server URL. So we can go down here after our class, and we can do API.add resource. And here we can pass in our predict class. And this will have the URL of predict. So whenever we access this URL path, we're going to have access to this post function. And the last thing we need to do for our Flask server is this if name equals underscore underscore main underscore underscore, and we will do app.run, and we'll set debug equal to true. Now this is just for our Python script. It's not important to understand it, so we can just skip that, but it is important for it to be here for our Flask server. So once this is done, we can try running our Flask server. Now I will activate an environment, and if you're unfamiliar with what an environment is, it's essentially a container that allows you to import Python packages. And so you can have multiple of these containers with different Python packages installed inside of them. So let's say you want one environment, Conda environment, to have TensorFlow version 3 or 2.3 and another one to have 1.2. Well, you can create different containers with each container having its own TensorFlow version. So here you can just activate that environment that you would like. So mine is called ML. Now I do have this that comes up. You won't have this, don't worry about this. But once we do that, let's try running our script by doing python human flask.py. And so we should not get any errors as long as, okay, so no module name keras.model. So for that, I thought we did that. From keras.models. Oh, so this needs to be plural. Sorry about that. So let's save and let's rerun. And so we'll just keep checking, and resource. Did I misspell this? Class predict. Oh, so in here, resource. All right, and now let's run it again. And so hopefully we don't have any errors. All this stuff here is fine. Okay, awesome. So we're getting all these TensorFlow. We got our model loaded. And so now we have our server running at this URL right here. And so we can go on to Google Chrome, paste this in, and now we won't find it. And the reason is because we have yet to add a section for our home page. But if we do go to predict, we will see this method is not allowed for the requested URL, and it's because we're not posting any data. We're not sending any data. And this function does require us to send data. But as you can see in our Flask server, we are interacting with our server from Google Chrome. And by doing this, we've successfully created a API that we can call to. And in the next video, we are going to create the Flutter code that will allow us to interact with this Python server. And we're going to send in our human sketch that we created in Flutter. So I hope you guys are very excited. I hope you guys learned a lot so far. We definitely learned a lot and a lot of valuable skills. And so I hope you guys are excited to finish this app off. All right, so let's create a function that allows us to interact with our API from Flutter. So the first thing that we're going to do is import a package. And so this package will be package http-http.dart. And by using this HTTP package, we are going to have access to connecting to APIs. And this is what we're going to use to connect, okay? So the first thing we're going to do is create some space in between this variable and our build function. And we're going to create a function called fetch response. And this fetch response will take in a variable called base64 image. And this is an asynchronous function, so we do want to specify asynced. But once we're done that, we can create a JSON data variable, and this is going to be var data equals JSON data. So here we'll have a key of image and a value of base64 image. Okay, so now this data variable is our JSON data that we'll be sending to our API. Now we want to create a URL, which is the URL of our Flask server. So we will do var URL equals http://. Now for our Flask API, let me just pull it up. You'll notice that our URL is 127.00.1 at port 5000. Now we can't connect to this port through our emulator. Okay, so if we no thanks, if we did 127.0.0.1 port port 5000. It won't tell us anything, and especially okay, let's redo it. 127.0.0.1 port 5000, and we want to go to predict, and as we did in Google Chrome, it should pop up here. So let's enter, and we get nothing. So a way to get around this is we want to connect to our home IP address. So our home IP address is represented by this 192.168.2.15.5000, and we want to go to the predict path that we created in our Flask server. So if you want to find your IP, you can go into command prompt and type in ipconfig, and it's going to give you all of the data for your IP. So you can just copy your IP and make sure it's the same. Now you may need to debug. This may not work for you, but this should work. But in the case that it doesn't, you may need to try different things. Maybe a different IP. Maybe try 127.0.0.1. But for my case, this is what worked for me. And now, if you're familiar with making a call to an API, you do need to pass in some headers. And these headers are just the settings of your API. So here we want a map of string by string. And we want to create a variable called headers, which will store a dictionary. And in this dictionary, we want content type, And this content type will be application JSON. So this is what is the content? What's the type of the content that we're sending to our server? Well, it's JSON. Okay. Next is the accept header. And what are we accepting? Well, we're accepting application.json or -json. And finally, we want a connection, and this will be keep alive, and this is just going to keep our server alive pretty well. Okay, so now we've set up the settings for our API, and now we can receive the data. So what we can do, well, there's actually one more step, and it's to encode our data dictionary here into JSON. So we can do var body equals JSON.encode, and we're going to pass in data. Now we do need to have JSON installed, I think. So it maybe, let's see which package it is. Convert. Yeah, so convert, and let's import one more library. Import Dart.io, because we will need that. And so, okay, so we encoded our data dictionary into JSON. So now it's ready to be sent in to our API. So we can we'll do a try block. And in this try block, we'll create a variable called response, and we'll set it equal to await.http.post, since it is an asynchronous function. And in this post, we want to pass in URL. We want to pass in body, and we'll set body equal to body. And finally, we want to pass in our headers. So we'll do headers is set equal to headers. And so undefined name HTTP. Do we not as HTTP? All right, so just make sure you append as HTTP after we import HTTP so that we can properly use it. So once we do that, well, we've made our API call. So now we have a response variable which holds all the data from our post. So this response is essentially holding the JSON data for our generated image. So we can do final map, and we're going to map string by string, or string by dynamic. Okay. And we're going to create a variable called response data, and this is going to be equal to JSON.decode, and we're going to decode the JSON in response.body. And essentially, this response data is also going to hold our JSON. So here, let's access our image key value and store the bytes. So we'll create a variable called string output bytes, and we'll set it equal to response data, and we're going to extract the image key. And so now we have the string, which is our key. Awesome. So now we have our byte data, and let's just append catch e, and here let's just say print error has occurred, and let's just return null for this case. Awesome. So that concludes this function here. Now we may add to it in a future lecture, although for now this should be good. If you do want to play around with it, when we do start sending data, we can start printing out output bytes and do all that sort of thing. So there is one more thing that we need to do, and it's display the output bytes, but we'll do that in a following video because we do need to create a function for that. So this is a good place to end off. Now in the next video, we're going to start building more of our Flutter application, and we're going to create a function that saves our image. So saves our sketch into an image so that we can send it to our data. So right now we only sketch onto the pad, and we have no way of converting this sketch into an image data type. Okay, so that's what we're going to do in the next video, and so I will see everyone there. Okay, now in the last lecture, we created the function that allows us to interact with our API. Now, we have yet to finish it off, although we did create this variable which stores the base64 representation of the generated image. So that's a very good point to be. So now what we need to do is we need to save the image that the user drew on the sketch. Now, to do that, let's create a new function, and this function will be returning void. So we'll do void save to image, and what this function will take in as a parameter is our list of points. So similar to this list, we can do list drawing area, and we'll pass in points. And this is an asynchronous function, so do make sure you put async. Now, we are going to need to import a new package, and this package is import Dart UI, and we'll do as UI. Awesome. Now, in this save to image function, let's create a variable called recorder, and this is just going to record our canvas. It's a simple, okay, so it's simply just recording our canvas, and that's what's going to allow us to save our image. So we can do final recorder equals UI.picture recorder. Next, we need to create a canvas, and we're redoing a lot of the code that we did for our sketch, and this is just the way I found to save our sketch into an image. So we're retaking this list of points, and we're just going to create an image out of those list of points. Okay, so we can do canvas equals canvas, and in here we want to pass in our recorder. We want to pass in rect.from points, and in here we want to pass in offset 0.0 by 0.0, and then we want another offset after this offset, so we can do offset 200 by 200, and that's just going to get us the canvas recorder. Okay, so that's just going to return the appropriate canvas for our sketch. Next, let's create a paint variable, and this paint variable will have similar properties to our canvas. So we'll set the color equal to colors.white. We'll set the stroke cap to stroke cap.round. And oh yeah, finally we need to add the stroke width, and this will be 2.0 and semicolon. And so these are just the parameters for our pen. Now we do need to add another paint variable, and this paint, oh sorry. So final paint 2 equals paint, and this is just going to be the background of our canvas. So we'll set style equal to painting style.fill, and the color will be equal to the background of our canvas, so colors.black. Now, if you do want to change the background color or the pen, you need to make sure you change it in the save to image and our sketch, our drawing area widget. Okay, so do make sure you stay consistent with your changes. Now, the next thing we're going to do is canvas.draw rect, and this is similar to the last, to our canvas. We are drawing a rect from LTWH, left top, so left top 0, width 256, height 256. Okay, and that's what's going on here. Okay, so we also need to pass in our paint 2, which will style our canvas. And so we need to put a similar function to what we did for our canvas, where we get the points that we listed out on our canvas. So we'll do this through a for loop. So we'll do for int I equals 0. I is less than points dot length, which is this variable that we passed in, minus 1, since we start at 0. And in this for loop, we want an if statement. So we'll do if points I does not equal null and points I plus 1 does not equal null, then what do we want? Well, we want to draw a line. So we can do canvas.draw line, and in draw line, sorry about that, we can pass in points I dot point, and following that, we'll pass in points I plus 1 dot point, and finally we'll pass in our paint variable. And so this is going to draw a line every time we have a point, and now we're recreating our canvas that we created from our sketch. So now after our for loop, we can do final picture, and we can set this equal to recorder dot end recording. Okay, and then we can do final image equals await picture to image. And so here we want our image to be 256 by 256. And so this image variable is now our sketch. Awesome. So now what we need to do is some further processing. So we can do final PNG bytes. So now we're converting it into PNG. And we can do this await image to byte data. And the format that we're going to pass in is UI.image byte format.png. Now, similar to our Flask server, this is the solution I found to saving our image. And as you may know, documentation on canvases and making drawing applications for Flutter are very limited. So I had to come up with a solution myself. Now, if you do find another solution, please let me know. This works for me, and it is scalable, so that's what's important for me. But then we're going to create a variable called listBytes, and this listBytes will be a uint8 list data type. So in this data type, we have to pass in png bytes dot buffer. And so now, what's going on? uint8 list. Do we need to import something for that? Let's see. Typed data. Oh yeah. So you do need to make sure you have typed data imported. But yeah. So once we do that, well, you can do file. So type file and a variable file equals await write bytes, and we're passing in list bytes. Okay, and this is going to create a file. Now, actually, let's skip this. Let's comment this out. I don't think we need it. But let's create a string, and the string will be base64, and this will be equal to base64 encode list bytes. Okay, so we're encoding our list, which is a uint8 list, into a base64. Okay, so now we have the base64 of our sketch. And as you may know, that's very important, because now we can send that. Awesome. We can send that to our Flask server. So we can do fetch response, which is our function, and we can pass in base64. Boom. So now we're sending in our base64 into our API, and we're doing the computation that we need. We're generating the image, and then we'll receive output bytes. How awesome is that? So now we can complete our application. So in the next video, we will continue building on top of this, and so I will see you there. Okay, so we built out our save to image function. we built out our fetch response function, and now we need to integrate it into our application. So to do that, if you remember, we have our gesture detector, and when we pan down, we create a line. When we update, we we create a line once again, and then when we end is when we lift up our finger. This is the case that we want to send our data to our API. And by doing this, every time we draw something on our sketch and lift up, we are going to generate an image. So inside of onPenEnd, what we can do is we can do save to image, and we can pass in our points, our current points. And so what that's going to do is it's going to call save to image. We're going to save this points list to an image. We're going to send the base64 representation of this sketch to our API. And what should happen is we should print out our output bytes. So here, let's do print output bytes. And so if I hot reload our application, let's also bring out our Flask server. So if I draw something, we should it should do that. So let me just see. So we're printing output bytes. Let's just say print starting request. And so what we should see, you can just, the shader errors are not going to stop us from doing this. So here, starting request, we are starting our request. Is our server running? Let's restart our server just in case. So okay, so for our Flask server, we do need to pass in a couple parameters so that we can properly instantiate it. So let's go back to our Flask server in Visual Studio Code. And in Visual Studio Code, let's create a comment at the top. And this is just for remembering sake. So the first thing that we need to do in command prompt is set Flask app equal to our file human flask.py. The next one will be set Flask env equal to development. And finally, we want to do Flask run host and equal to the host that we created. So 192.168.2.15. So here, you may not understand it yet, but what we are going to do is copy this first command, and this is just for instantiating our Flask server. So inside of our command prompt, let's paste that first command. And so this is going to set our Flask app equal to this Python file. Next, we're going to set our environment. Oh, what happened there? That's weird. So let's just copy this once again, paste it in this, and now let's run our Flask server. So before we used Python, and that just compiled our Flask servers to make sure that we didn't have any errors, but now we are actually running our Flask server. So by doing that, we'll get very similar output, and we'll get all this TensorFlow code saying our model is being configured. And so now our API is up and running. So what should happen is I can draw something, and we should see, awesome. So we got 200, and 200 means it's successful. And we got our base64 encoded string. Beautiful. Now, if you notice, we are getting a quotation B quotation, and that's not part of our base64. So we do need to remove that from our string. So we can do that now. So let's see. Where do we print that information out? So we print it out in fetch response, and here we print out output bytes. So output bytes is our 50 by 50 human generated image. So now let's get rid of this B quotation mark. And what I found works is we can do print.substring, and this gives us a substring, and we can start from index 2, so 0, 1, and start from here. And we can end at output bytes dot length subtracted by 1, because in some cases there is a quotation here. So we do want to make sure that we don't get that quotation. So let's hot reload our app. And what we should see happen is the quotation at the beginning is gone. Beautiful. And there's no quotation there. So now we have the byte representation of our data. So in the next lecture, we're going to display our generated image inside of Flutter. And that will bring us one step closer to completing this application. So I hope you guys are very excited. And so let's get this on the road. All right. So the first thing that we're going to do is go to the top of our state class here, and below our points variable, we're going to create another variable, and this variable will be of type widget, and this widget will be called image output, and this is where we're going to store our generated image. So let's create a function following our fetch response function, and this function will be called void display response image. And here we're going to take in a string of bytes, and this will be an asynchronous function, so we do need to specify the async keyword. Now in here, let's create a variable called of type uint a list. And if you're unfamiliar with this data type, I do recommend doing a quick Google search on it. It's very similar to base64. But here, let's create a uint 8list converted bytes variable, and this is going to be equal to base64 decode, and we're going to decode the bytes that we pass into this function. And so we are getting an undefined. Oh, did I misspell it? Yeah, I did. So capital L. Sorry about that. All right. So here we've successfully got our converted bytes, and we've decoded the bytes from our Flask server. This is the function that will be called once we receive the data from our Flask server. And so here what we want to do is set the state, and the state that we want to change. What is going on here? All right, we want to set image output equal to a container widget. And this container widget will have a width of 256, a height of 256, and as you may remember, our image was 50 by 50 so that we can send in less data. And in here, so we're going to fit it to this 256 by 256. So in this child, we'll have image.memory, since we are getting this image from memory, and we're going to pass in converted bytes. And in here, we also want to put a fit parameter so that we can properly resize it to the format that we want, and we'll do boxfit.cover. Awesome. So let's just put the semicolon. And so now we have this function which displays an image based off the bytes that we pass in. Cool. So we're ready for the next lecture, and in the next lecture we're going to pass in the bytes and call this function inside of fetch response. So I hope you guys are excited, and I will see you in the next video. Alright, so every time we make a call to our API, we do want to display the generated image that we received from our API. So in order to do that, we have this output bytes, which prints out bytes every time we draw something on our sketch, right? So these bytes represent the generated image, and you can see that it's scalable, and we can do this infinite amount of times, and it's just going to do it over and over again. I think that's super cool. But now what we can do is we can do display response image, which is the function that we created in the last video, which takes in bytes and stores it in this image output widget that we also created in the last video. Now, what we want to send in display response output is this exact substring that we did in the last video, if I recall. And so now we're displaying this response image, and we're storing the bytes of the generated image in this image output widget. So now, you guessed it, what we need to do is just display our image output on our Flutter application. So in order to do that, we are going to put the image output below this this white container. And so let's go after our white container, which is this row here. Okay, and in this row we have a container. So following this container, we want to create a new widget. And this widget will have a padding of edge insets dot symmetric, and we're going to put a padding on the vertical axis at 10. Following that, we will have a child of this padding container, and the child will also be a container. And inside of this container, we will have a center widget, and inside of the center widget, we will have a clip r. Actually, inside of the center widget, we want another container, and this container will have a height of 256, a width of 256, and a child of, you guessed it, image output. Boom. So what do you think is going to happen now? I think that if we hot restart our application, when we draw a sketch, well, hopefully everything works out. If it doesn't, then we made an error somewhere. Let's just put, oops. Let's save. So when we draw a sketch, we should see our generated image. Let's do it. Okay, boom. That's what I'm talking about. Look how, isn't that so cool? You're generating a human right now. You're generating a human. Look. And this is just off one epoch. Now, we can continue training our model, and we can get even better results. I think it's so cool. I hope you guys are. I played with this for like 5 hours, and I showed my whole family. I showed everyone, all my friends, and my girlfriend. And my girlfriend's an artist, so she did some cool stuff, and it was really interesting for her to see because, having AI generate art is extremely cool and futuristic. And yeah, she got a really good result because she's a good artist and she knew how to draw a human. But yeah, so now we've generated our human. And that's the conclusion of this course. And I hope you guys learned a lot. Now, if you do want better results, you can either use the neural network that I trained overnight, over a couple nights, or you can train your own. Now, you can use any sort of data set that you want. You can use, I don't know, you can use the bag one that we saw in TensorFlow in Google Colab, or you can use a shoe one, or you can do a Pokemon generator. You can do all sorts of cool things with this app. I was also talking to one of my friends, and I did mention it earlier in this course. This can be very helpful for police officers where they receive a sketch of a suspect and they can generate a realistic image of that suspect, which is also a very practical application. I don't think it's being done today, so maybe if you can go to your local police station, show them this app, and maybe make a deal with them and make a quick 100K. I'm joking, but yeah, this is a really cool app, and it's a very powerful technology, and I hope you guys show me what ideas you come with this algorithm. There's a lot of potential with this algorithm, and if you guys do continue building an application with this, please show me. I love seeing what my students build. It makes me want to keep teaching, and so yeah, I hope you guys are as happy as I am for this result, and I will see you in the next course.